course, no one paid attention.
Yes, because it's a sub.
Not just a sub, we were also all 7th graders.
Yeah, that says something, doesn't it? All right.
My trig teacher always get injured.
Wow. Trigonometry is a violent sport, huh?
All my sister had him, and so every year he gets injured because he's with the sports.
Oh, he does coaching.
Yeah, he does.
You should stay on the sidelines more. All right. Cotangent of 420. Use the fact that the trig functions are periodic to find the exact value of the given expression. Do not use a calculator. So I've got to be able to do this without a calculator. So you know what to do about this already, right? What do you do with 420? You subtract 360. Huh? It's more than a full circle. This is cake for you guys. See, I told you how this would be so easy for you. Cotangent was at 60. Okay, and then you can just go to the unit circle. You'll put the unit circle on your 3x5 card for the 4th exam. So anyway, now how do you cotan? Do you remember what that is? 1 over tangent. Tangent, remember, is sine over cosine, right? So this will be cosine over sine, right, of 60 over sine of 60. Let's go to the unit circle. Look at 60 degrees, find cosine and sine. Oh, it's not here. I got to go grab it. Where is it? There it is. Okay, so 60 degrees, right here. Cosine's a half, sine's root 3 over 2, right? So cosine's a half, sine's root 3 over 2. You know, grab that denominator, flip it up. So we get a half times 2 over root 3. These cancel. 1 over root 3. What do you do with the square root in the denominator? Multiply top and bottom by root 3. Root 3 over plane 3. Cotan is 60 degrees. Easy for you guys. I'll move.
Just divided by 2, right?
So what is it? Secant 26 pi? What's the answer?
2 pi.
Final answer.
Secant is 1 over 0. Wait.
1. All right, let's see it. Secant of 26 pi. So secant, first time we do 26 pi, that's just a bunch of 2 pi's, isn't it? Right? You can just keep subtracting 2 pi's. 2 pi, 2 pi. And if you do, you get all the way down to 0. You with me? Because that's just the origin. Not the origin. I mean, that's the starting angle, right? That's starting right here. That's the same as 0 degrees. They've just got around 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14, 16, 18, 20, 22, 24, 26. That's just 13 full circles, isn't it? So really, you've gone nowhere. You're right where you started. It's 13. It's like driving in a circle 13 times. You've gone nowhere. So it's secant of 0. And what is secant? 1 over cosine.
Which is 1.
And go to the unit circle. Cosine of 0. Cosine sine. Cosine's 1. 1 over 1, 1. There we go. Easy, right? Easy. Okay. Cotan of 13 pi over 3. All right, what are we going to do?
Minus 2.
Take out some 2 pi's. Right, take out some 2 pi's. So how do we deal with the frac? You okay with all the fractions and everything? We need to subtract some 2 pi's there. So take 13 pi over 3 and subtract 2 pi. And 2 pi is 2 pi over 1. Multiply top and bottom by 3. 6 pi over 3. Everybody with me on that? That's a fancy version of 2 pi. With common denominator, right? So that brings it down to 7 pi over 3, and then we can take out another 6 pi over 3, which is again another 2 pi, and we're left with just pi over 3. So this question boils down to cotan of pi over 3. Once I take out the two pi's, the 6 pi over 3 twice. So it's cotan pi over 3. Go to the, which is
1/2.
Is that what it is? Cosine over sine.
Oh, 1/2 over.
Cosine over sine. So cosine, so I'm going to go to the insert cosine pi over 3. So we go to pi over 3, which is right here. Cosine's a half. Sine's root 3 over 2. Cosine's a half. Sine's root 3. Grab this, flip it up. 1/2 times 2 over root 3. 2's cancel. 1 over root 3. Multiply top and bottom by root 3. Root 3 over 3. Good. These are easy for you. A lot of steps, but
I just figured that if it's, I just went up. from the chart.
Went up from the chart?
Yeah, like if I figured that how many times.
Oh, you just knew it was a bunch of two
Yeah,
pi's
then
and
I
then
just
up
went
1
to-
pi over 3, huh?
Yeah, I just went to that and I just did the word.
Yep.
Oh, maybe it's
That's
right
right.
there.
All right. Positive and negative signs.
All students take calculus.
Oh, yes. All students take calculus. Is that true? Are you all taking calculus?
Next year.
Maybe.
Maybe,
I
maybe
signed
not.
up for it with when.
All students take calculus. I don't think that's true. My daughters, they loved, this is how they memorized all their pluses and minuses when they took trig, and they loved the all students take calculus. And one of my daughters took this class, and she will never take math again. She never took calc, and she's very happy to be done with math. All right, so all students take calc, so maybe not. So, I mean, they're all positive here. It means all 6 trig functions are positive there. In this quadrant, it means sine and his reciprocal, which is cosecant. Remember, that's the upside down sign. They're positive. The other 4 are negative. This tells you which trig functions are positive in which quadrant. So they're all 6. This means all 6 trig functions are positive in the first. In the second quadrant, only sine and his upside down, cosecant, are positive. In this quadrant, only tangent and his upside down, cotan, are positive. The other 4 are negative. And in the fourth quadrant, what's C stand for? Cosine and his upside down, secant, are positive. The other 4 are negative. So all students take calculus stands for all sine, tangent, cosine. And their upside downs are positive. The other 4 are negative in the second, third, and fourth quadrants. All 6 are positive in the first. So that's an easy way to remember the quadrants. So when they say, okay, this is a quadrant, you know how they go, 1, 2, 3, 4. So sine is positive, cotangent is negative. So sine positive. So right away you're either here or here. You with me? If sine is positive, you're either in the quadrant where they're all positive or the quadrant where sine is positive. In these quadrants, sine would be negative. So we're not in 3 or 4, just because sine is positive. Now, if something else is negative, then we ain't here.
Then we're on 2.
We're in quadrant 2. I don't know why they don't put them in order, but there we go. Quadrant 2. We're in quadrant 2. Everybody see that? Because not everything's positive, so we're not in quadrant 1, and sine is positive, so we're in quadrant 2. All students take calculus. Not true. Try that one. See if you can find that.
Quadrant 3.
Yeah, quadrant 3. Y'all getting that? It can't be, they're not, these are both negative, aren't they? Secant is negative, sine is negative. So we're not in the first quadrant where everything's positive. We're not here where sine is positive because they're saying sine is negative. We're not here where cosine is positive because cosine's upside down is secant. And they're saying secant's not. So all that's left is quadrant 3. Easy? All students take calculus? Yeah? Okay, so they're given as sine and they're given as cosine. They want the other 4. So you all know how to do that, right? Let's go through it and see what you remember. How do we get tangent? What's the definition of tangent? Sine over cosine. So that'll be the negative 3 root 10 over 10 over cosine root 10 over 10. You know what to do with fractions over fractions. And you grab the one on the bottom, flip it up, so it'll be times 10 over root 10. Good so far. 10s cancel, root 10s cancel, minus 3. Is that good so far? So now we have tangent. How do we get cotan?
Flip it.
Yeah, it's 1 over tangent. It's the flip of the tangent, isn't it? So 1 over negative 3? Or negative 1/3? For cotan. And then how do we get, let me come up here, how do we get cosecant? You flip sine, huh? 1 over sine. 1 over sine is the same thing as turning sine upside down, because it would be on the bottom and flip up, right? So I'm just going to take the sine and flip it upside down. So minus 10 over 3 root 10, like that. Is that good? Can't have a root on the bottom. So you know what we do. Multiply top and bottom by root 10. So we get minus 10 root 10 over 3. And what's root 10 on the bottom do? Plain 10. And the 10's cancel. Minus root 10 over 3. That's cosecant. We're just flipping now, right? We're just flipping these. And finally, secant. What is secant? It's the flip of cosine. Same thing. You just take cosine and you turn it upside down. Can't have a square root on the bottom. So we go, okay, times root 10 over root 10. And so, is that what that is? 10 root 10 over plane 10. 2 root 10s make plane 10. 10s cancel root 10. And there we go. We got all 6. Everybody good with that? Tangent's just sine over cosine, and then the other 3 are just flip it, aren't they? Good? All right. It looks like it's good for you. Okay. They're giving me cosine, and they're saying I'm in quadrant 3. Find the other trig functions. So this is a little different. Last time, you see the difference. Last time they gave me sine and cosine. So that was easy. Tangent's just sine over cosine, and then the other 3, flip it. But how am I, if they just give me cosine, how can I do it just from that information? What can I do if they just give me cosine, nothing else?
Sine is x over
Do the
r.
draw.
The
It's
triangle.
25 by r.
The third side, the y.
Yeah, you've probably done some of this. We're going to draw the triangle. Yeah, so these are a little more complex. This is really important. We'll finish this one, but we'll do more of these when we come back from Thanksgiving break. But yeah, let's these are real important. Let's actually draw one. And this is important because you do this in calculus. If you're going on to calculus, you have to do this for some stuff you do in calc. So let's put it in quadrant 3. What I'm going to do now is I'm going to make a triangle in quadrant 3. Now remember, when we make our triangles, we always make the angles reference angles. What does that mean again? What's a reference angle? Oh, I'm sorry, I haven't said it. I said that like I've said it a million times. I'm teaching trig right now, and I've said it to them in this very room maybe over 100 times. But I haven't to you guys. So do you remember what a reference angle is from your trig experience?
The angle is
Angle to the x-axis. A reference angle is an angle off of the x-axis, not the y. Why? Why the x-axis? Because that's where 0 starts. They could have made trig. They could have said 0 is straight up. They totally could have. This was just made up. They could have said 0 is straight up, and then everything's from there. They could have. But they decided to make it straight to the right, which is the x-axis. So everything is with reference to the x-axis. So when I say reference, so when I make the triangle in the third quadrant, watch, it's not like this. I'm not going to make it like that. Why? Because he's hitting the y. I don't want to make it on the y-axis. I want to make them on the x-axis. So I'll make it go like that, hitting the x-axis. That makes sense? So always make your triangles hitting the x-axis because your original 0 is on the x-axis. So you want everything with reference to the x-axis, and it'll carry forth the same. Okay, so there it is. We're on the x-axis. Now, and I'm going to put theta right here. Now technically, theta is really all the way from 0 to there. That's really what theta is, but it's the same thing as the reference angle in the third quadrant to the x-axis. The values are the same. Maybe I'll prove some of that later. Let's just go forward for now and crank out this problem. I'm saying, now if I put the theta here, that would be wrong. Theta to the y-axis is not the same. It's got to be the one to the x-axis, between your line and the x-axis, right? An angle is an amount of opening between two lines, isn't it? So I'm saying the angle theta has to be to the x-axis. Okay, so now, cosine is negative 24 over 25. Do you remember the SOHCAHTOA thing?
yeah, x over r.
Oh, man.
Remember that? Is it all coming back? Like a happy time from the past?
My sinking boat? Oh, yeah.
We'll make that boat float this time. All right. SOHCAHTOA means sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse, and tangent is opposite over adjacent, right? We good? So put that angle theta right there. So now if that's the angle theta, first off, which side's the hypotenuse? This side, the one across from the right angle, right? If this is the right angle, then this is the side not touching it. See how the other two hit the right angle? Side across from the right angle, longest side, hypotenuse, okay? That's hypotenuse. Now, this angle theta, so the other two are adjacent and opposite. What does adjacent mean? Next to you. Like my neighbor lives adjacent to me, next to me. So which other side is next to that theta?
Right there.
This side, huh? So what is the side opposite? Well, this one.
Across, yeah.
We good? So from that angle's perspective, that's opposite. This is hypotenuse from any angle's perspective. And this is adjacent from that angle's perspective. Okay. So whereas it'd be different if I put theta down here, which would be wrong. It's got to be to the x-axis. But I just want to let you know. Then the hypotenuse wouldn't change. The hypotenuse is the hypotenuse is the hypotenuse. That's not changing. But this would then be opposite, and this would be adjacent, huh? You with me on how that works? Anyway, we can't do that. That'd be wrong. Can't put the angle there. Theta's got to be the x-axis. Opposite, adjacent. Okay. So what? Well, it says cosine is negative 24 over 20. Just put that negative on the top. Right, remember, a negative on a fraction, you can put it on the top only, or the bottom only, either one. I'll put it on top. Okay, so cosine, and that is what? Adjacent. Right here it says cosine is adjacent over hypotenuse. So the adjacent is negative 24. This is negative 24. And the hypotenuse is 25. See how we're doing that? And so now, is coming back as a happy memory row? All right. And now we can find, we have the Pythagorean theorem, huh? We can find that third side, and then we can get all the trig functions from there. So call this y, because it's up and down if you want, or you can call it x. It doesn't really matter. I'll call it y. So negative 24 squared plus y squared is 25. So it's a right triangle. A squared plus b squared is c squared, Pythagorean theorem, right? 24 squared is like 576 or something.
Yep.
Done it so many times. And this is 625, and
49.
that's a nice number. 49, nice. Root it. So y is 7.
Actually, it's
Negative 7.
Yeah, you can tell from the picture that it's actually down 7. Now, yeah, you can tell it's back 24, down 7. If you're careful to put the signs on like we just did, saying, hey, well, that's got to be negative 7 because it's down like y'all are saying, great. Then your sine, cosine, tangent, everything will work out perfectly, signs and all. If you don't want to mess with that, you could just call it 7 and get all the answers and fix the signs when you're done with the all students take calculus. Because, right, all students take. We know we're in this quadrant. Tangent, only tangent is positive, and his upside down cotan. The other four have to be negative. So you can just fix it at the end. That's how my daughters always, I tried to tell them about the negative down there. Whatever, Dad, we'll just do the all students take calculus. They didn't want to mess with all that along the way. So whatever works for you. All right, so let's get all the trig functions now. So here we go. So so we got cosine. They wanted sine. What is sine? Opposite over hypotenuse. This is the opposite here. So opposite, negative 7 over hypotenuse 25. Negative 7 over 25.
All
Good.
of that for that.
Well, they want the other four too.
Oh, sweet.
Okay, so we'll do tangent. What's tangent? Opposite over hypotenuse. So opposite over hypotenuse. Negative 7 over 25. No, that can't be. Oh, it's... Yeah, what am I doing? Thank you. I just totally said the wrong thing there. I was testing you. Negative 7 over negative 24. Two negatives.
Positive.
Sure, no, because we knew it had to come out positive, right? Because we're in the tangent. All students take calculus. Tangent. It's got to be positive. All right. And then the other ones are by flip, 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 right? The other three are flip, flip, flip. So cotan is going to be, flip it upside down. And then cosecant, that's just going to be upside down of sine, negative 25/7. And the upside down of cosine is secant, so that'd be negative 25/24. There we go. So drawing those triangles in a certain quadrant and all that, use the Pythagorean and all that, that's real important. There'll be several problems with that, and that's in calculus as well. Good on that. Let's see if we can squeeze one in and we'll be done. Wow. All right, let's try this one. Cosine theta is minus 7/10. What does that mean right there?
It's in the
It's within a
third
certain.
quadrant.
That's
It's
directing
the
me,
second.
it's directing me to my car in my parking lot to get the hell out.
That's second quadrant. Everybody see that second quadrant?
Yeah.
So remember, pi's 180, so that's 180
E divided by 2.
to theta is between 180, so theta is between 90 and 180, right? So here's 90, here's 180. They're saying it's quadrant 2, huh? So make a triangle in quadrant 2. Now, you're going to make the triangle connect to which axis?
To the y-axis?
X.
There's only two choices. The x-axis, right? Because reference angle is always x-axis.
Yeah.
Because 0 starts on the x-axis. That's why that has to be that way. So in other words, don't make your triangle like this. Don't have it hit like that on the y, right? Don't connect it to the y. Have it. It always comes from the origin. It's always from the origin, and you connect it to the x like that. So connect it to the x-axis, and the angle is right there. You always put the angle right at the origin to the x-axis, like that. And then put in the cosine theta as minus 7/10. So this is opposite, adjacent, hypotenuse. SOHCAHTOA, we're going to run out of time, aren't we?
We're
SOHCAHTOA.
running out of time. We're out of time.
Cosine is adjacent over hypotenuse. So adjacent is minus 7. Hypotenuse is 10. Pythagorean, and that's all we have for today.